morning everyone. Welcome from IIT Kanpur, and this is part I am here to talk to about the yet another lecture of the part of the course called Artificial Intelligence in Industrial and Management Engineering. I am Professor Deepa Philip. I am from IIT Kanpur, and this course is offered as part of the NPTEL MOOCs content created from IIT Kanpur. Along with me, Dr. Prabal Pratap Singh also co-teaches this course. In the previous lecture, we were doing on expert systems, and we are continuing with the expert systems, and we were just starting the discussions on symbol confidence calculus. So, on the screen, I just wanted to show you what we discussed briefly. It's about how the symbol confidence calculus yield an intuitive degree of belief, and for each fact we are assigning a number between 0 and 1, and for each rule we are assigning a rule confidence between 0 and 1. So, now let us get into the ground rules of the confidence calculus. Okay. So, first one is confidence of premises of a rule. Okay. This is which is equal to minimum confidence of each condition then second one is intuition TUITION, intuition, okay, that is strength of the argument is the weakest link. Okay, the strength of the argument is the weakest link. So, that is the first one. Then second one is confidence in conclusion of a rule. Okay. So, the premises of a rule, minimum confidence of each condition, and intuition is the strength of the argument, which is of the weakest link, and confidence in conclusion of a rule, which is equal to confidence in rule premises, okay, that is one, multiplied by confidence in the rule, So, that is the ground rules for this. Now, confidence in conclusion from several rules, okay, say R1, R2, etc., Rm with confidences C1, C2, etc., Cm will be equal to C1 the rate, C2 the rate, etc., Cm, where x at the rate y is 1 minus 1 minus x times 1 minus y. Okay. So, this value, okay, you have confidence C1, C2, C3 at the rate, the rate operator means it is 1 minus x times 1 minus y. So, simple, the confidence of premises of a rule is minimum confidence in the each condition, and intuition is the strength of the argument, which is the weakest link, and in the confidence in the conclusion of a rule is a product of confidence in the rule premises multiplied by confidence in the rule. And if you have multiple rules, then we use the rate operator, which is 1 minus x times 1 minus y. So, let us work an example, okay, as we did earlier. The earlier example, the mid-claw one, let us do that. Okay. Facts F1, mid-claw gives milk, gives milk 0.9. Okay. F2, mid-claw eats meat 0.8. F3 mid-claw has hoofs 0.7. Okay. So, what we are doing is we are now giving a what you call as a confidence for each fact, we are assigning a confidence. So, the confidence of the fact is we have assigned at this point is 0.9, mid-claw gives you milk, mid-claw eats meat and mid-claw has hoofs. Then the next thing is we give say rules. Okay. If R1 gives, if X gives milk, then it is a mammal. Okay. That's 0.6. Okay. R2, if X is a mammal and eats meat, this is the second rule, then carnivore, we give it as a 0.5. Okay. R3, if X has hoofs, then X is carnivore. Okay. Let us say we change the rule now, instead of mesonecia we just said carnivore 0.4. So, each one of the rule we are given a rule confidence. So, these are the rule confidences. Okay. And if you look into this, each fact degree of belief. So, this is the degree of belief. Okay. All right. So, now let us continue. So, do the sample calculations. Okay. So, now let us do how the sample calculations comes in. R1 with F1, mid-claw is a mammal. Okay. That is fact 4. Okay. So, how does we get into this? R1, if X gives milk, then it is a mammal. So, R1 combined with F1 gives you mid-claw is a mammal. So, that is the fact 4, R1 with F1. Confidence of F4 is equal to CF4 is 0.9 times 0.6, which is equal to 0.54. Okay. Now, R2 using F2 and F4 yields. So, if you saying R2 using F2 and F4, so R2 using F4 and F2. Okay. So, mid-claw eats meat and mid-claw is a mammal. So, if you do that, both of those yields, mid-claw is carnivore, that is F5. Okay. C of F5, the confidence in the rule F5 is okay. So, that is from R2 equal to minimum of 0.54, 0.8 times 0.5 equal to 0.27. So, how do we get that? So, let us go back to this one. So, you can see that R2 using F2 and F4, R2 using F2 and F4. Okay. So, R2 if X is a mammal and eats meat, then carnivore, that is 0.5. Okay. F4 we have already seen what is it, it is 0.54. Okay. And F2 is mid-claw eats meat, that is 0.8. So, when you have previously if you look into it, then we can see that we have already mentioned that the minimum is what we would like to use, minimum confidence of each condition. So, that way we will say minimum of 0.54 which is fact 4 and 0.8 which is fact 2. So, 0.8 is part of F2, this is part of F4. Okay. And then where is this 0.5 coming from? 0.5 is coming from the X is a mammal and eats meat. So, this is R2. Okay. doing this we get 0.27. Okay. Now, R3 using F3 conclude F5 from R3. Okay. R3 using fact 3. Fact 3 is, we already seen what is fact 3. Midclaw has hoops, okay, which is at 0.7 degree of belief. Using F3 conclude F5 on R3. Okay. F5 is what we have calculated 0.27 and R3 is, R3 has hoops, the next is a carnivore. So, let us do that. The C of F5, okay, from R3, you can make the conclusion from through this fact also, equal to 0.7 multiplied by 0.4 is equal to 0.28. So, now the last one is C of F5 from R3 and R2 equal to 0.27 multiplied at the rate 0.28, which is equal to 1 minus 0.28 multiplied by 1 minus 0.27, okay, which is equal to 0.48. Okay. So, that is the way you can calculate this. So, this based on this rule degree of belief that is given to the rules, this is the degree of beliefs, these three are the degree of beliefs, and based on the rule premises that is given, okay, the rule confidence, these three we can create a calculus, and from there we can calculate the confidence in each one of the conclusions that we get out of this. Okay. Now, why we need to explain the reasoning process? So, we help the user understand the system behavior. Okay. So, that is the first part. Second one is, people do not always accept the answers, accept the answers of an expert without some form of justification. Okay. So, is most of the time if the answers of an expert requires an justification. Okay. So, if the expert is a machine, okay, that is what it is. Okay. Specifically if the expert is a machine, then presenting the chain of reasoning constructed by the system. Presenting the chain of reasoning constructed by the system, okay, which is important in, this is important. Now, if we go back, we are saying that presenting the chain of reasoning constructed by the system, okay, which is important. Okay, why this chain of is very important? It is important in explaining. So, presenting the chain of reasoning constructed by the system, this is because it is not human expert, and this is important because in explaining the success or failure of the reasoning process. So, we have an issue trusting the machine, okay, and hence because we need to go through that chain of reasoning and then decide how to come with the whether it is a success or failure, the reasoning process has a success or failure. Okay. So, now with this craziness, now let us think about a revised expert system structure. Let us now see how the expert system structure changes. Remember, if we go back, we had seen this components of the expert system, right? Major components, user interface, inference engine, knowledge base. Now, with this, how would we go back and do revising the expert system? So, let us say first box we do is knowledge base rules, okay. And then the second one we do is, as we said earlier, we drew earlier, that is draw the second box, inference engine. This is the agenda, okay. And then we have, let's take a third one, working memory, is facts. So, you remember earlier that these three were connected, okay, in series, okay, interconnected with them. Then we also have new approach or new mechanisms or new, I will call it as explanation facility, okay, and then we have knowledge acquisition facility, okay. And then we have what we call as the last one being user interface, okay. Now, these are connected. The user interface is connected to this, the explanation facility is connected to the inference engine, same way, like this way, okay. So, the revised expert system, if you look into the previous one, the original thought process was a linear mechanism. Now, we have revised this because we know that we already mentioned that we need some justification, especially if it is a machine. So, then that means we need to add explanation facility. This explains the reasoning process, okay. And this facilitates addition of new knowledge. So, the user interface, instead of just a vertical thing, has also now explanation facility and as well as knowledge acquisition facility. And the inference engine, as we said earlier, it is the agenda, right, the knowledge base, that is the rules, and then the working memory, which is the facts, okay. So, this completes the revised expert system structure. Now, what are the benefits of the expert system? Let us look into the why do we need to have expert system and what are its benefits. So, helps preserve knowledge. Let us help to preserve the knowledge. Then helps when expertise is scarce. Expensive or unavailable, okay. So, when you are expensive or expertise which is scarce or expensive or unavailable, then expert system is right. Then, as we said earlier, it also helps you to preserve knowledge because experts die, okay. Remember, human experts die, okay. Helps if decision maker is under time and pressure constraints. So, if the decision maker is under time and pressure constraints, then the decision maker can have improved decision quality, and then increased output and productivity. Okay. So, if the decision maker is under time and pressure constraint, then you can use the expert system to improve the decision quality and increase the output and productivity. Then it also helps in training new employees. Okay. So, new employee training, it's some of the HR function. Okay. So, one way to think about it is intelligent tutor. Okay. Then that is also the non-expert lecture or knowledge transfer to remote locations. Okay. So, intelligent tutor and or the other option is we can also do knowledge transfer to remote locations as well. Now, if that is the case, what are the problems and limitations of expert system? It's expert system, it's a computer system as I said earlier, and people look at it from different standpoint. So, the first key point is knowledge is not always readily available. Okay. The knowledge is not always readily available at all. Okay. That is the first issue. The second issue is expertise can be hard to extract from humans. So, if you have a human expert, how do you extract the expertise? Okay. So, it is usually very hard to extract the expertise from the human being. That is the other second aspect. The third aspect is expert systems work well only in, there is a limitation, only in a narrow domain of knowledge. The expert system only work in a very narrow domain of knowledge. Now, then the fourth one is knowledge engineers are rare and expensive. Okay. They are very rare and they are expensive. I use the term knowledge engineers because instead of expert system engineers, so they are into, let us call them as knowledge engineers for the time being. Expert systems are expensive to design and maintain. So, they are expensive to design and maintain. Okay. Then sixth point is lack of trust by end users. Okay. So, what does that mean? Lack of trust by end users. Okay. In the simplest way to say it is aka we are still dealing with a computer. Okay. So, this belief or this concept that we are still dealing with a computer is the other aspect. Then the last aspect is inability to learn. Okay. So, that is the another major lacuna or limitation of expert system is its inability to learn, because its learning is limited to the facts and the rules that is provided. It cannot synthesize facts and rules by itself. and add new things into it unless human intervention is available. So, if you look into this, the first thing is knowledge is not always readily available. That is the first limited problem with the expert system. Then it is very difficult or hard to extract the knowledge, expertise from the human beings. That is the second aspect. Okay, and it only works well, okay, well in a very narrow domain of knowledge. Expert systems work well in a very narrow domain of knowledge, and knowledge engineers or the people who design expert systems are very rare and expensive. The last one is expert systems are expensive to design and maintain. So, to build and maintain, it is very difficult to, it is expensive, you will need to spend a lot of money. And then one another major issue is lack of trust by end users, because of the thought process that we are still dealing with a computer. And the last one is inability to learn. So, concluding today's thing, so it was a long lecture, but you should know that we looked into what is a confidence calculus, which is used in many of the expert system designs, and how that the premises and conclusions of the rules and the operator also, and what is the degree of belief and the rule confidence what it is, and how some of the sample calculations are taken as part of it. Then why do we need to explain the reasoning process, and then we proposed a revised expert system structure, and now then we talked about the benefits of the expert system, and we also finally concluded with the problems and limitations of the expert system. So, with this we come to the end of today's lecture, and probably the end of this week's lecture as well. So, please continue to read and get yourself updated. In the next week, we will talk about some aspects of local search, heuristics, etc., which should probably conclude before we move into the applications of it in the industrial engineering. Thank you very much.